this is Unit 9, Lesson 3, and in this unit or lesson we're going to be graphing rational functions. So last time we took a look at what happens when they were an inverse function, which just meant simply that our numerator was a variable, a number, like in this example right here, and we talked about how you can figure out your asymptotes simply by looking at the function. Well, what we're going to get into today is taking a look at what happens when it's not written like this. When it's written as one fraction and you have variables in both your numerator and your denominator. We can still easily figure out our asymptotes, but it may not be as obvious in this case. We're also going to be talking about some new concepts in regards to wholes and figure out really how to finish graphing these things. Okay, so let's just kind of do a quick review of what our asymptotes are and what a vertical asymptote is. So just remember, it's a vertical line in which the graph approaches but never actually touches. Your graph will never touch a vertical asymptote. Okay, and in our examples the other day, in every function we only had one vertical asymptote, but it is possible to have more than one. So we will see that today and see what the graphs look like in that case. But as you can tell in this example, this one had a vertical asymptote at x equals 2, because remember we're looking for variables, or sorry, numbers that when we substitute it back in are going to give us an x value of 0. It's going to make that denominator undefined. So the graph does not appear at that location. All right, now a new concept will be to talk about a hole or point of discontinuity. Oh, sorry about that. Okay, so we call it pretty much a hole in the graph, and it literally is a hole in the graph, and you'll see how I draw that. But really, it's just another way to identify a number that when you substitute into your denominator would give you an undefined denominator. And we'll talk about the difference between a hole and a vertical asymptote and how you distinguish between the two. All right. I guess I go into it here, but so it's when you factor your numerator and your denominator, if you have a factor in common on the top and the bottom that you can cancel, that itself will determine a whole. Any remaining factors left over will be your vertical asymptote. And like I said, we'll go into that. And then last time we talked about a horizontal asymptote, and that's a line horizontally that our graph approaches. Now, I mentioned in class that it can cross a horizontal asymptote. Your graph can. It's really more for indicating your end behavior, what's going to happen at the end of the graph. So don't freak out if you're graphing, you're like, oh, it's crossing my horizontal asymptote. That's possible towards the middle of your graph. That can happen, but it will never, ever, ever cross a vertical asymptote, okay? And we'll talk about how to find all of these things. So just a reminder, a rational function is when you have two separate polynomials. They can be written as a fraction, but of course your denominator cannot be equal to 0. Any numbers that you substitute in there that would equal 0 indicate either an asymptote or a whole. All right, and then your vertical asymptotes are when you factor something out. If there's no common factors, it's those factors in your denominator that would make it 0. Okay, so let's take a look at our first example. And for some reason, one second, I'm going to pause you for 1 second. Okay, I'm back. Sorry, for some reason the graphs didn't show up on it, so I had to reload that. Okay, anyways, so let's find the vertical asymptote. So the first thing you want to do, notice this is not an inverse form because I don't have a just a plain number on top. I have a variable up there, so it doesn't matter. At the end of the day, we're going to find our vertical asymptotes the same way. It's whatever number that when you substitute it into your denominator is going to make it 0. If you can factor, you need to factor it first. Okay, in our last example, like if you look at number 2 down here, that's something more so that we looked at last class, and it would need to be factored, so that's okay. We'll just factor. So our denominator here factors into x minus 1 and x plus 1. So that's telling me I have 2 vertical asymptotes, okay? So I'm going to dash in a line at -1, dash, 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 and at +1. Okay, so for right now we're just finding our vertical asymptotes. We'll come back later and take a look at what those graphs look like. But because that's x minus 1, that's telling me that vertical asymptote is at x equals 1, and this one's at x equals a -1. Okay, all right, so taking a look at number 1 over here, same thing. Let's go ahead and factor out that denominator. So x minus 3 and x plus 3. Sorry, my handwriting's off. I left the quarter on overnight, so I have to be plugged in to do this. Okay, so dash it in at x equals -3 and x equals +3. Remember, I'm getting those by just setting each factor equal to 0 and solving. All right, in number 2, it doesn't need to be factored, so I simply have x equals -4. And I can dash in that line at -4, dash, 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 dash. Right over here, I mean, my numerator can be factored. We'll talk about wholes and canceling all in a minute, but just showing you that it can be. But I have nothing in common, so my asymptote is just x equals -1. And just a reminder, our asymptote is a line. So if I'm asking you for the equation, or if I'm just asking you what it is, it's an equation. It's x equals -1. Right over here at number 4, that can be factored. So first I want to pull out a GCF. Okay, now the GCF itself is not telling me it's a whole, it's just something to help me factor it down. So that's a positive x squared, that's a positive x, and that would be a -6 because I'm dividing everything by -2. Okay, so two numbers that multiply to +6 and add up to 1 are +3 and -2. Okay, so that means that the asymptote is at a, sorry, -3, x equals -3, and at x equals +2 because we put those equals 0. Okay, so those are our vertical asymptotes. And there's a reminder, always check to see if any factors cancel that would indicate a whole instead of a vertical asymptote. Now, none of these examples had it. If I were to factor this numerator out, I could pull out an x, which would leave me at x minus 4. Okay, so there's no common factors. We'll look at shortly when you do have common factors, what that's going to mean with a whole. All right, now, horizontal asymptotes, okay? Horizontal asymptotes, like if it's written in an inverse variation form, we saw it was a number being added or subtracted out here. However, when it's not, when we have variables in the top, it's not as simple as that. This one's a smidge bit different. Okay, so just a reminder, horizontal asymptotes, we can find them by looking at the degrees of p of x and q of x. Okay, degree mean the highest exponent that we see. So there's 3 different scenarios that we need to look at. So situation A tells us that if the degree in the numerator is less than the degree in the denominator, okay, so maybe on top you have an x squared and then your denominator you have an x cubed. Okay, but if the degree in the numerator is smaller than the denominator, it will always be y equals 0. Okay, always be y equals 0. If the degree is equal, okay, so they're both x's, or they're both x squares, or they're both x cubes, then it's going to be the ratio of the leading coefficients, okay, and we'll look at that example, but it's going to be the ratio of leading coefficients. So sometimes it will be a fraction, sometimes it'll be like 4/1, and you'll get a whole number. If the degree is bigger in the numerator than in the denominator, okay, so in part A, it was the numerator smaller. Part C is if the numerator is bigger. We won't have a horizontal asymptote. We'll have what's called a slant asymptote, and we'll be looking at that in just a moment in 2 pages or so of what to do with a slant asymptote. So it's more of like a slanty line as opposed to horizontal. You can never have both a slant and a horizontal. It has to be one or the other. A horizontal asymptote is more common, so just keep that in mind. Okay, so let's take a look and let's figure out what's going on here. First of all, let's also review our verticals while we're at here. So let's go ahead and factor that denominator. I have x minus 1 and x plus 1. Okay, so let's go ahead and dash in our vertical asymptotes. Okay, the more we practice, the easier it becomes. Dash, 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 dash. Yes, I'm going to do that every time. Dash, 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 dash. Okay, so let's figure out what our horizontal asymptote is now. So to find it, we're going to look and say, okay, what's the degree in the numerator? It's 1 because that's an x to the first. What's the degree in my denominator? 2 because it's an x squared. So then you have to say, okay, are they the same or are they different? Well, they're different. Since the bottom is bigger, that's going to be a y equals 0. Okay, so that's where I'm dashing that in. Now, if you notice, there's kind of like, since there are 2 vertical asymptotes, it's going to change it. We're not just going to have those 2 swoops. And we will come in and figure out how to graph all these shortly. But it's going to have 3 pieces to the graph, and we'll take a look at that. Okay, looking at number, whatever this is, nothing can be factored, but if I were to graph a vertical asymptote, to be x equals 1/2. How did I get that? Just set this equal to 0 and solve. So it's a positive 1/2. So in that case, you just do your best to be at the 1/2. Okay, so for my my horizontal, degree on the top is 1 because that's next to the first. The degree on the bottom is 1. Okay, so since they're the same degree, this is the situation where it's going to be the ratio of the leading coefficient. So look at the numbers in front, and it's 3/2. So it's y equals 3/2, or 1.5. Okay, so this is also going to be a fraction. So 3/2 is at 1.5, and we just dash it in. Okay, so that's my horizontal asymptote. All right, let's take a look at this one. All right, so first of all, once again, let's find our denominator, our verticals. Numerator can't be factored, so I have x equals 1/2 for my vertical. All right, now the numerator has a degree of 2, denominator's degree of 1. So this is a slant, okay, or it's sometimes called oblique asymptote. So we're going to come back and we're going to flip to the next page and figure out how to find it, and then we'll come back and actually do these to find the actual equation, but it's going to be a slanty line, okay? We're not going to have a straight horizontal one because the degree in the numerator is bigger than your denominator. So let's figure out how to find our slants, and we'll come back and we'll do it. Okay, so a slant or oblique asymptote, it's neither vertical nor horizontal. All right, so when we talked about y, if the degree in the numerator is bigger than the denominator, so what we have to do is we have to use long division in order to find out the equation. And we're only going to look at the quotient part, not the remainder. We're going to kind of ignore that. So it doesn't matter if you have a remainder or not. Some other things to talk about are that there may be 0 or 1, but you'll never have more than one slant asymptote. You also never have more than one horizontal. The only type you can have more than one is a vertical. All right, and you can't have both you cannot have both horizontal and slant. All right, so slant asymptotes are drawn using a dashed line also, but it's going through the line y equals mx plus b. So that's what you're graphing, and you're going to get that from doing the division. Okay, so let's take a look at this example here. So here's the original function. You know, normally I would try to factor and cancel, but I can't factor that because that's a sum of perfect squares, which are not factorable. So it can't be factored, so nothing cancels. So what we're going to do is set up long division, which you can see I already did down here for you in this first one. Okay, don't forget to, when we do long division, fill in any missing terms like we have here. There's no x term. All right, so we divide. X squared divided by x leaves me with x. X times x is x squared. X times -1 is negative x. Okay, and then we subtract. Those cancel. I have 0 minus a negative, so that's a positive x. And I can bring down my 1. All right, x divided by x is 1. Okay, multiply, x times 1 is x, -1. Okay, subtract, I'm running out of room, sorry. So those cancel, and I have 1 minus -1 is 2. Okay, so it's x plus 1 is my quotient. That's what this part is. And then the remainder is 2. Once again, don't really care so much about the remainder for this part. It's the quotient that I'm going to be graphing. And you treat it like in a line, okay? It should be a line, y equals x plus 1. All right, now remember, if I were to graph this, here is my y-intercept, here's my slope, 1. Okay, so we can go ahead and let's put in our vertical asymptote. It's x equals a positive 1. I got that from looking at my denominator in the original problem. So we're going to go ahead and dash that in. Dash, 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 dash. All right, now we're going to graph our slant asymptote using this right here. So I'm starting at a positive 1, okay, and go up 1 and over 1. So I'm going to put a couple dots for now and then dash my line in just to make it a little bit easier to see what's going on. So remember, this is not a function. This is, you know, just kind of an asymptote here. All right, so what's this going to look like? Well, let's take a look. So the easiest way, and when we kind of go back to graph, you do need to be able to graph these by hand. Sorry. So we are going to want to find 1 or 2 points on each side. So what I do is kind of treat this like your center. And I'm going to pick like 2 x values to the right of that and 2 x values to the left, just to kind of get a general feel, a general picture. So if I'm going to pick 2 and 3. And then I'm also going to pick 0 and -1. I also want to try to find any intercepts, which is kind of nice because I'm finding my y-intercept right here. So I'm plugging this back into the original problem, and I get, when I substitute -1 back in up here, I get 2 over -2, so it's -1, -1. Okay, so I can go ahead and put a dot down there. All right, if I substitute 0 in, I get 0, -1. Now that can happen sometimes, and it's because that if you were to look at this on a calculator, it's always going to be curvy. So don't be like, oh, it's a straight line. So kind of what happens is it comes and it hugs it, and it does come up a smidge and then comes back down and hugs it. Sorry, that looks so jaggedy. For right now, I'm not going to make you find this kind of maximum point. We'll take a look at how to do that on our calculator and calculate the maximum, which you guys have seen before, but I'm not so worried about that right now, and that's not something you would have to do by hand even next year. Okay, moving on. So as long as we can get a couple concrete points, you get the idea, kind of just follows along. Remember, those are the asymptotes. It kind of hugs, the graph hugs those. All right, so let's figure out what's going on over here. So if I were to substitute 2 in, um, 4 plus 1 is 5 over 2 minus, so 5 over 1. So I've got 2 comma 5. So I'm just finding a couple points. All right, and then if I were to substitute 3 in, I get 10 over 2, which is 5 also. That's not always going to happen where there's 2 the same, but it, just be aware. Okay, these kind of have a mind of their own. It's not like a, oops, sorry, but you get the idea. It's, oops, sorry, I didn't mean that to cross. Like that. Okay, so that's what a slant's going to look like. It's kind of more of a sideways parabola-esque. Now, if you want to find this, we can actually find the x-intercept here, right, by plugging 0 in for y. So 0 equals x squared plus 1 over x minus 1. So to clear that denominator out, we're going to multiply both sides by x minus 1, which multiplied by 0 goes away. So really I just have 0 equals x squared plus 1. Okay, so that's telling me it doesn't cross my x. How do I know? Because I'm taking the square root of a negative number, so it's imaginary, so it doesn't actually come up and cross. But that's a very good thing. We should always be checking for our x and y intercepts. All right, so let's go back a page now and let's figure out how to find the slant asymptote here, okay? So what we're going to do once again is we're going to set up a division problem. We've got 2x minus 1, and then we've got 3x squared plus 0x plus 1. Okay, so now we're doing 3x squared divided by 2x. Well, that gives me a fraction. Okay, that's okay. So I have 3 over 2x. That's a 3, I swear. When I multiply that back out, I end up getting, it's 6 over 2, so it's 3. So 3x squared. And 3/2 x times negative 1 is negative 3/2 x. Okay, go ahead and subtract them. Those cancel. 0 minus a negative is a positive, so I've got 3/2 x. I'm going to go ahead and bring down that 1. All right, so I've got 3/2 divided by 2. So 3/2 divided by 2 is the same thing as 3/2 times 1/2, right, which is also known as 3/4. Okay, so multiplying through when we get back to the 3/2 x. 3/4 times negative 1 is negative 3/4. Okay, at the end of the day, I'm going to get a remainder. This is what I care about. That's my line I'm graphing. So my slant asymptote is at y equals 3/2 x plus 3/4. Okay, so it's going to be a little bit, well, a little different to graph. I don't have it doesn't matter that my slope is a fraction, but my y-intercept is 3/4, so we'll just make do. Okay, but I also found that point. That is for my asymptote. So I'm going to go up 3 from here. So 1, 2, 3, and over 2. Okay, I can go down 3, 1, 2, 3, and over 2. So remember, this isn't the function. That is just my slant asymptote. Dash, 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 dash. Okay, so we need to go ahead and graph it now. Get this out of the way. So when I do this, I'm going to set up a little mini table, or however I want to organize. Not too picky on this, as long as you get me some points. So I want it to be like 1 or 2 to the left. So my vertical asymptote's at 1/2. So I'm going to do negative 1 and 0. And then I'm going to do positive 1 and 2. Okay, so if I plug negative 1 in, I get 3 times 3, 4 over negative 3, right? 2 times negative 1 is negative 2, so 4. Okay, so negative 1, negative 1 and a third. Okay, so we just do the best we can, which is about right there. I'm going to do it in a different color so we don't confuse the asymptote. Okay, and then if I plug 0 in, we get 1 over negative 1, so 0 at negative 1. And that's also my y asymptote. So it looks like it's going to kind of hug here, come up, curve around, and come back down. Once again, you can check to see if you're going to have an x-intercept. We probably should do that first to see if it's going to come up here at all. I don't believe it will, but it doesn't hurt to check. So if I plug 0 in, I know that when those are going to cancel out. So same thing's going to happen since it's not factorable. I move my -1 over and I have -1 equals 3x squared. When I take a square root, I'm going to have imaginary. So there is no x-intercept there, okay? So if I plug 1 in, I get 1 squared times 3 is 3 plus 1 is 4. And then I get 4 over 1, so it's at the point 1, 4, right here. All right, when I plug 2 in, I get 2 squared is 4 times 3 is 12, so I get 13 over 2 times 2 is 4, so 13 over 3, which is 4 1/3. So a little smidge there. So it's kind of like comes down and then loops back around and hugs it once again. All right, so find that vertical asymptote by looking at your denominator. Find the slant asymptote by doing long division and looking at the quotient and treating like that, like the equation of a line. All right, so at this point, I'm going to pause the video. I want you to try numbers 1 through 4 on your own. The directions say identify the horizontal or the slant asymptote. Okay, so you got to look at and figure out what it's going to be based on the degrees and then find the equation. So please go ahead and pause the video and try this on your own. Pause it. All right, so let's take a look. In the first two, they're both the same degree, so it's just the ratio of leading coefficients. So the first one is 1/3. And then the second one is y equals 1/4. In example number 3, your denominator degree is bigger than your numerator, so that's y equals 0. In your number 4, it's a slant or oblique asymptote because the degree in the numerator is bigger than the degree in the denominator, so we had to go through and do long division, okay? So it divided through, and I end up with 1/4 x minus 1. So down here, up 1 over 4, down 1 over 4 this direction. So that would be my slant asymptote line. Y equals 1/4 x minus 1. All right, let's continue on. We already did that page. Okay, so let's just put it all together and let's graph some things now. We kind of started in a few of them, but let's take a look. So the first thing you want to do is to factor, if you can, find out your asymptotes and your holes. And actually, let's not pause, but let's talk about holes because we didn't do that yet. No, I'm sorry, there aren't any in these examples. We'll worry about that after. Okay, so this one cannot be factored, but we have a vertical asymptote at x equals 1/2. So let's go ahead and dash that in. Dash, 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 dash. So looking at it, it's going to be a slant asymptote because the numerator is bigger than the denominator. So we're going to go ahead and, did we actually divide this one out already? This looks familiar. Am I just making that up? Nope, just making it up. Just kidding. Sorry. No, we did right here. Okay, so just because we already did the work here, it was this one down here. So it was at y equals 3/2 x plus 3/4. That was our slant asymptote from dividing it out. 3/2 x and 3/4. Okay, so once again, we started up here at 3/4 and up 3, 1, 2, 3 over 2. I know we already graphed this one, just kind of doing a quick review of it. Okay, and down 3, 1, 2, 3, and over 2. Now you would be using a straight edge so that your asymptotes actually are a line, which will help you graph it better. Okay, and then we want to find some points. So what we did back in this one, let me just scooch back here, is we made a little table of values to find points on both sides. And this is where we talked about looking for your intercepts, okay? So we had points at -1 and -1 1/3, 0 and -1. Use different color. 0, -1, -1 down here. So kind of just like hug the asymptote. It's not supposed to be on top. It's just my bad drawing. And this one, if you recall, was here at 2 and 4 1/3 and 1 and 4. Those were those points. So 1 and 4 and 2 and 4 1/3. So kind of hugging, coming around and looking like this. They're kind of like check marks sideways-ish. All right, number 2, this one's kind of interesting. So nothing, first of all, factors. So, but when you look at your denominator, if you were to set that equal to 0 and solve, you're going to get imaginary asymptotes. Mind blown. Don't worry, there aren't imaginary asymptotes, okay? It's either there or it's not. So in this case, we actually don't have any vertical asymptotes. We do have a horizontal one though, okay? But we have no vertical asymptotes. So that'll be pretty interesting when we go ahead and graph it. But so to find it, different degrees, so we have an asymptote at y equals 0. Now, remember, the graph can go through a horizontal. All it really does is kind of tell us about our end behavior, what your ends are approaching. So let's kind of figure out some points here. We can go ahead and figure out our x and our y. Well, won't probably, oh yeah, whatever. Let's figure out our y-intercept. So let's plug in 0. So that means I get 0 over 1. Okay, which you can have, people, it's 0. And we talked about that, it can cross. Okay, and then if I plug in 1, I plug that in. I do my math. 2 times 1 is 2. 2 over 2 is 1, so I'm at 1, 1. Okay, if I plug 2 in, 2 times 2 is 4. Over 5, 4/5, so 2 and 4/5, so it's coming back down. Okay, and I'm going to talk about that in a second. And then you plug 3 in, you end up with 3/5, so it's going to get closer. Okay, now on this side, what happens? If I plug -1 in, I get -1. If I plug -2 in, I get -4/5. They're kind of like symmetrical esque. So this ends up happening. So it can cross a horizontal asymptote, but it's always going to come back down towards it, because remember I told you your horizontal asymptote is talking about your end behavior. So as x continues to approach infinity, it's not going to cross it again. The values are going to get closer and closer and closer and closer to 0, but never touch it. Same thing down here. It comes down, but then it comes back up. And as it's approaching negative infinity, it's getting closer and closer to 0. So your horizontal asymptote still will talk about that end behavior even if it crosses it in the middle. It kind of crosses it and then will come back down in both directions. Okay, so that's why this one was on here, so you could see it. All right, number 3. So I have a vertical asymptote at -1, x equals -1. Dash, 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 dash. All right, same degree, so my horizontal is at the ratio, so 2 over 1. So y equals 2. Okay, so we're going to go ahead and use a quick little plug in a couple values to get a general idea. I'm going to plug in 0, get my intercept. So if I plug in 0 up here, I end up with 1 over 1. So 0, 1. So you can't really tell for sure which quadrant. So you kind of just got to plug in some numbers and see what happens. Don't be afraid to do math. If I plug 1 in, I get 2 plus 1 is 3. 3 over 2. So it's at 1 and 3/2. So it's kind of like this. And if you're not sure, plug some more in, okay? Can't use the excuse of I didn't know what was happening if you're substituting values in. All right, on this side, I'm going to plug -2 in. So I get -4 plus 1 is -3. That's plus 1. And then in the bottom, I plug in -2 and 1, I get -1. So it's at +3. And if you want to plug -3 in to see if we can get another solid point there, you get -6, -5 over -2, so it's 2.5. Okay, which makes sense. It's kind of coming back down here. All right, so there's our graph. All right, so now let's talk about holes, okay? Let's talk about those holes. So let's factor, all right? Both my numerator and my denominator. They factor into x minus 1 and x plus 1. My denominator factors into x plus 1 and x plus 2. So a hole will be if there's any common factors. So it is a discontinuity, can't say that, in the denominator, but that's going to be a hole at x equals -1, okay? So x equals, or x plus 1, so therefore x equals -1 gives us a hole. And it's going to be an actual point, which we'll come back to in just a moment. And then this will be an asymptote. Something can't be both an asymptote and a hole. They have to somehow show where the graph doesn't touch or doesn't exist, but it's a hole if it ends up canceling. It's an asymptote if it's just a lonely factor in the denominator. So I'm going to have a vertical asymptote at -2, so let's dash that in. Dash, 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 dash. Horizontal asymptote is going to be at, they're the same degree, so at 0. Okay, so now we're going to have to deal with a hole. So in order to find the hole, it tells us right here, there's a hole at the x value where the denominators cancel. Determine the x value by setting the cancel term to 0. We already did that. So calculate the y value of the hole by putting that number back into the reduced fraction. So we don't need to put it back in with what we canceled out. So I'm going to plug 1 back into this. So x minus 1 over x plus 2. So I'm going to plug 1 in, and I'm solving for the y variable now, or the y number of that hole. Okay? Oh, no, sorry, that should be a -1, guys. Why didn't you tell me? Right, because I canceled the x plus 1 factor, so x and -1. So I've got -1 minus 1 over -1 plus 2. So it ends up being -2 over 1. So it's at -2. So that tells me the hole itself is at -1, -2. Okay, so right at that point, I'm going to literally draw a hole. Okay, so when my graph goes near there, it's just going to be just like an open circle on something, okay? All right, so let's kind of figure out where else our graph is going. So let's plug in 0 and kind of just, I'm assuming it's going to go like this, but let's just take a look. Let's find our y-intercept. So if I plug 0 in, and I can do it into either, it shouldn't matter, but let's work. If I plug 0 in here, I get -1 over 2. So it's 0, -1/2. So that's my y-intercept. Always good to find it. Always good to find x-intercepts if they exist. And a lot of times you may not have an x-intercept, no big deal. Okay, so then I just kind of draw it, making sure it's going closer to my asymptote, and then down here. Okay. So there's a discontinuity. There is no part of the graph right there or the whole asymptote. All right, now I need to find out what's going on over here. Now, they're always kitty corner from each other, or whatever that phrase is. So it's going to be up here, but just got to double check. Plug in the -3. I get -4 over -1, so it's at 3 positive 4, because you're never really quite sure how far away that point's going to be. We talked about how to find it in an inverse variation graph, but not as obvious here. So plug in -4, so I get -5 over -2, so positive 2/2. And you can keep going if you want to get more points. If you want to plug in 5, I get 4 over, wait, no, sorry, -5. -6 over -3, so -5, 2. So kind of just give you an idea of what your graph is looking like there. All right, so there's my graph. All right, so I have 3 practice examples for you. What I'm asking you to also go back and practice identifying those intercepts, those domain and range, what we did with our inverse variation. All right, so please go ahead, pause the video. You're going to do it on your own. Don't forget to factor. In the first one, I factored it for you. Find any holes, find your asymptotes, find your intercepts, and then from there, graph it and identify your characteristics. So there's 3 of them. Go through and work on them on your own. When you press play again, the information will be on the screen. Let's go ahead and pause. All right, take a look at this example. So this is kind of something for asymptotes. There's going to be one of 2 different situations that happen. Okay, it can look like this. There's always going to be, when there's 2 asymptotes, 3 pieces. So there's always one more piece than there is space. So you're going to have this where there's 2 asymptotes, and you can have, I call these the wings. And the middle part will be parabola. So these are going to look like that. And my asymptotes, the wings will be, the wing down here, and the parabola that. And there's no way to really know from looking at your equation. You just have to substitute numbers in and kind of see what the general trend is. So when I graphed this one, I got like 1/22, 1/9. So you just got to know like your fractions, what's bigger and smaller. So as I was plotting these, as these moved away, the y values were getting closer to 0. So I knew it had to be like coming up here like that. Okay, then same thing on the other side. So when there's 3 pieces, the middle part's going to be a parabola, and the other 2 are going to be the wings on the opposite side of that horizontal asymptote. The other thing that it could look like is that when you have the 2 verticals, that middle component could be a kick, and then you have the 2 wings there opposite each other, like our normal rational function we see. And you really have to just substitute some values in to kind of figure out the general trend. So you also need to have a good number sense to know bigger and smaller and all that good stuff. Okay, but you can see my graph. Any point you need to pause, please do. So there was no, or I had a hole at -4. Oh, I forgot to draw my hole in. Have a -4, 1/9. So where is that going to be at here? -3. Wait, was my hole at -4? Hold on, let me scroll up. Okay, so I just put a little hole where it's crossing the 4 for now, because I can't particularly draw well. My intercept is 0 at -1/3. Vertical asymptotes, horizontal asymptote. Increasing, decreasing uses your x value. So you're using your your asymptotes and holes. And actually, ever since I forgot my hole, I need to not have another one here. So increasing negative. Now for this piece right here, the increasing to -3, increasing from -3, 0. And it's notice it's going up here and then it turns. Now, I'm not letting you use a calculator right now. Typically, you would calculate that max value and use the x of it to find the where it's turning again. For right now, just guesstimate, and that's okay. Okay, I'm saying at 0 is probably more closer to negative fraction something, but that's good. And then end behavior is always your horizontal asymptote. So that part at least will stay the same. This is going on over here. All right, let's take a look at the next one. Okay, let's take a look at these last two. All right, so this first one this is what happens when you have the cubic in the middle. All right, so when you're creating your table of values, you're just finding some points. You've just got to be able to, once again, have number sense, know what's going on. I plotted 3 points here, and I saw that, you know, it's not making a U, so therefore it's going to make a cubic, okay? And then I figured out which side my things are going by finding 1 point on each and realizing, okay, so they're going to go, I call them once again the wings, they're going in opposite directions. And then from there I could fill in my characteristics. So go ahead, take a look at those, and please do bring any questions to me. I have slant asymptote. I have a vertical asymptote at -1, and my slant was at x - 4. So it's this green line down here, -4 with a slope of 1. Okay, and then from there I found some values and found out general picture of it, and I filled in my characteristics. So once again, pause the video, take a look at those, and come back with questions.